Okay, this is the overview for factoring, which is our first unit in the math refresher program. And so just a few bullet points here and a few reminders about um, the basic elements of factoring and expression. And the intent here is just to remind you about things that should be well learned and well practiced from the high school experience, and just to be looking for that structure because you're going to see that the same types of problems, and oftentimes just an extension of the same type of problem. So the structure will look the same, uh, but the concept might have a little more cumbersome number in it or something. To start, I also want to mention that factoring um, is nothing more than division. When you're factoring, you're dividing. Um, and sometimes that's something that's lost on students, or so we want to remind you of that. The first thing you do when you have an expression and you want to factor it, you want to split it apart, is to look for a common multiple. And by a common multiple, we mean a common variable between terms, a common coefficient between terms, or and of course a constant uh, multiplied value for all terms in the expression. And then secondly, you want to always be watching for special cases, and we'll identify a few of those over this week. Um, Things that you can factor just because you've seen that sort of relationship between things before. And so getting to know types of situations that you can and how to react to those in just a moment's notice. And finally, factoring by grouping, pairwise factoring of expressions. Um, so I put up three examples here just to sort of remind you of those things, and then of course the pretest will be there for you. Try the pretest, self-assess your skills. If you have questions about these examples or about the pretest, get back to us, and we'll try to answer them here in the video format. Now this first expression um, is x to the third power times y minus 4xy. And so if we're going to factor this, we look at the terms, we see that they both share x's, and of course they both share y's. Now, in terms of the x's, we have x to the third, and we have x to the first. And the general rule of thumb is to factor out the lowest power you see. So since we have x to the third, we have x to the first, we're going to factor out x to the first power. Likewise, they both share an x, rather a y, and so we're also going to factor out a y. And when we do that, we remember we're dividing, so x to the third divided by x is going to be x squared, because you subtract those exponents, right? When you divide expressions for the same base, you subtract the exponents. And y divided by y, of course, is a 1, and then a minus sign. The 4 is going to remain uh, there. And of course, the xy divided by the xy, that's also going to become a multiple of 1. Now, that's good, that's factored, but of course, it's not complete. And right in here would be a real identifiable special case, a difference of squares. And anytime you have a difference of squares, that should be very, very easy to factor. And of course, we're going to factor this to x plus 2 times x minus 2. And so there's our fully factored expression. Now notice we don't set each piece equal to 0 or anything like that. These are not equations that you're dealing with. They're expressions. There's no equal sign here, so we're not looking for an answer. We're not trying to say x equals 2 or x equals negative 2 or x equals 0. We're merely factoring the expression. The second example over here is a little more calculus-like, in that number 1 we have fractional exponents, right? We have x to the 3 halves power, we have x to the 1 half power, and we have x to the minus 1 half power. In addition addition to that, I have a coefficient of 3, a coefficient of minus 9, and a coefficient of 6. So real clear, I think we have a multiple of 3. They're all multiples of 3. And they are all multiples of x. Now, what did we just say of when you have a common variable and they're two different powers? Well, the general rule, again, is to factor out the lowest power you see. And the lowest power we see here is the x to the minus 1 half. So I'm going to factor out x to the minus 1 half. And what that means is I'm going to be dividing each of these terms by 3x to the minus 1 half. Well, of course, 3 divided by 3, that's going to be 1 right there. And then x to the 3 halves divided by x to the minus 1 half. You should remember the rule for when you divide numbers with the same base, you subtract the exponents. In other words, this is equal to x to the 3 halves minus 1 half. And of course, when you subtract the negative, that's going to be addition. So we're going to have x to the 4 halves, or more succinctly put, we're going to have x squared right there. All right. Now the minus 9 divided by the 3 is going to leave us with a minus 3 on that middle term. And again, we have x to the 1 half, and we're factoring out an x to the minus 1 half. So if we do that, we subtract those exponents, we get 1 half minus 1 half. And again, because we're subtracting the negative, that's going to be addition right there. And so we've got x to the first power. And finally, this plus 6x to the minus 1 half is going to be a plus 2, because 6 divided by 3 is 2. And the x to the minus 1 half divided by x to the minus 1 half becomes a multiple of 1. And that would be fine, except that the trinomial can be factored a little bit further. And that should be pretty obvious how that's going to factor. It's going to be an x and an x. We know that both signs in these binomials will be negative. And finally, multiples of 2, 2 being a prime number, there's only one pair of numbers that'll do that, 1 and 2. It doesn't matter what order you put them in there. And so that is a fully factored form. But there's a little bit more I want to say about this in terms of this negative exponent right here. That negative exponent, since it's multiplied, what I can do with that negative exponent is move it to the denominator, thereby making that exponent positive. So this negative 1 half right here, I'm going to do with that, let me just rewrite it over here. 3x to the minus 1 half, and then we have the x minus 1 and the x minus 2. What I'm saying is this term right here, this x to the minus 1 half, I'm going to move that to the denominator, thereby allowing me to change the sign of that exponent and also making something else very apparent. So we move it downstairs, makes it a positive 1 half. It also makes it apparent that x cannot be 0, because if x was allowed to be 0, that would then um, make an undefined expression. Right? So this is disallowed. In other words, x equals 0 is not in the domain of the expression, we would say. So you want to be wary of things like that. Any number that would cause an expression to be invalid, you want to make a note to yourself of that. Very important in the calculus. Now, this final example down here is an example of the factoring by grouping technique, and that's nothing more than pairwise factoring. And if you look at the first pair, you see x cubed minus 3x squared. Obviously, both multiples of x. We factor out the smallest power, so we're going to factor out x squared. And factoring that out, we're dividing. So x cubed divided by x squared is going to be just an x and a minus sign. And 3x squared divided by x squared is a 3. And then as you look at the last pair, you can see that they're both multiples of 4. And I'm actually going to factor out a negative And by factoring out that negative 4, when negative 4x gets divided by negative 4, that's going to leave me with a positive x right there. And the plus 12 divided by the minus 4 is going to leave me with a minus 3 in there. And now, if you compare the two pairwise factorings we just did, you can see that they have a common element of x minus 3. So I'm going to factor out from each of those terms, I'm going to factor out the x minus 3. Right? Just like our first example where they both shared a y, and we factor out that y. Here they both share an x minus 3, so we're going to factor out that x minus 3, and that's going to leave me with an x squared, because if I have x squared times x minus 3 and I divide out x minus 3, it leaves me with an x squared. And the second term, the 4 times, the minus 4 times x minus 3, when we divide out the x minus 3, that's going to leave me with a minus 4. Okay, so we factored it using that pairwise factoring. But again, right here, the x squared minus 4 should be an old friend. And so we'll take this expression over here to do our final factored form. And that would be x minus 3 times x plus 2 times x minus 2. And so when we do that, we get our fully factored, our completely factored form. And again, I want to remind you that that's the end right there. You don't go further and set each factor equal to 0. We saw a lot of that in the readiness test. This would be your final answer for when they give you an expression and tell you to factor it completely. Don't confuse roots or zeros of an expression with the factored form. All right, we did see quite a bit of that in the readiness test where we a couple expressions that we had students factoring, and they were coming back and telling us what x equaled. In all of these examples, there was no equation. These were just expressions. So try to keep those two ideas separate. So from here, we'll say try the pretest, see how you do. If you have questions, you can check in on the answers to the pretest on Tuesday, and late Tuesday they should be up there for you. And if you have questions, get back to us.